going to be solving rational equations and inequalities. You can check out some examples in Chapter 8, Section 5 of your book. I'll be using the problems from examples 1, 2, and 6. So let's go ahead and get started. We have x plus 8 over x equals 6. So to solve this, we're going to use some of the things that we've learned before. So we're going to start out with a pretty easy one here. Okay, whenever you've got something like this and we don't really want any fractions, so to get rid of that, what we can do is multiply everything by whatever this denominator is. So I've got 8 over x, so to get rid of that, I would multiply that by x, right? But to keep this thing equal, let's multiply everything by x so that way it stays proportionate. So x times x, we would get x squared plus 8 over x times x, that cancels, so now we just have 8 equals 6x. If we had been dividing multiple things, say that had been an x over 2 and an 8 over x, we multiply everything by 2x. We want to multiply everything so that all of the denominators cancel out at once. Let's get this all on one side of the equal sign. So we'll have x squared minus 6x plus 8 equals 0. And then does this factor? What multiplies to positive 8 and adds to negative 6? Well, that's negative 4 and negative 2. So here we'll get x equals 4 and x equals 2. But we always want to go back and check our answer to make sure that it works. So if we plugged in the 4 back in the original, so if we had 4 plus 8 over 4 equal to 6, 8 over 4 is 2, so that'd be 6 equals 6, and that works out. And then to check the 2, I would have 2 plus 8 over 2 equals 6, so that'd be 2 plus 4. And in the end, we also get 6 equals 6, and that works out. So our solutions are both x equals 4 and x equals 2. Okay, so let's look at another example. We're going to still be solving. And here we've got 3 over x minus 3 equals 2 over x plus 3 over x minus 3. So if I'm wanting to get rid of the x minus 3, you could think of this in two ways. You could either cross multiply, or you could multiply both sides by the x minus 3. In the end, I mean, you'd still be doing the same thing. So if I multiply each side by x minus 3, those two things would go away, and then we would have 3x equals 2x plus 3. If I subtract 2x from both sides, I'll get x equals 3. But don't forget, we still want to go back and check our answer. So if we have a 3 here, and we plugged it in, we have 3 times x is 3 over 3 minus 3 equals 2 times 3 plus 3 over 3 minus 3. Well, in both of these parts right here for the denominators, we would get 0. And that is not allowed to be equal to 0 because it would be undefined. So it's undefined for x equal to 3, so that's not our solution. Instead, we would have no solution. Here's another example. So we have 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. Okay, so we've got different denominators here, but as we referenced earlier, if they are different denominators, we need to get that least common denominator. And we would have x minus 7 and 2 in both of those factors would be in the denominator. So what I need to do here is get rid of all of these fractions. I want to make all of the fractions go away so I just have a single line of information. And I'm going to get a least common denominator here. And that would be 2 and x minus 7. So if I multiply each thing by 2 and x minus 7, that would cancel out with the least common denominator. Let me show you what I mean here. Okay, so I'm going to multiply each of these things by 2 and x minus 7. So I'm going to multiply 2 and x minus 7. 2, and I'm not multiplying the top and the bottom, I'm just multiplying straight across everything by 2 and x minus 7. So notice this, if I have 2x minus 9 times 2 over x minus 7, then the x minus 7s would cancel, and we'd be left with the 2 times, whoops, 2 times 2x minus 9. On the next part, the 2's would cancel, so I'd be left with x times x minus 7 equals, here the x minus 7's would cancel, so I'd be left with 5 times 2. So at this point, if I distribute out, I'd have 4x minus 18 plus x squared minus 7x equals 10. If I collect like terms and get it on one side, let's see, we've got an x squared. 4x minus 7x is a negative 3x, and then we have a negative 18. Subtract over the 10, we get negative 28. Let's see if this factors. Are there any factors that multiply to negative 28 but add to negative 3? And we could get negative 7 and positive 4. So the solutions, we get x equals 7 and x equals negative 4. Don't forget that we need to check these. So if I go back and I check in at the 7, so I'd have 2 times 7 minus 9 over 7 minus 7. Okay, I could write out the rest of this, but, well, might as well. Okay, there's 2 problems here. And it's that we had that 7 minus 7, that would end up canceling out to 0, and that would be undefined, and we can not have an undefined solution. So x equals 7, that is not going to be part of our solution. So let's check out the negative 4. So we'd have 2 times negative 4 minus 9 over negative 4 minus 7 plus negative 4 over 2 equals 5 over negative 4 minus 7. So you could go through and simplify all of this if you'd like, but I can see that nothing will be undefined, so it should all work out, and then that would be my answer right there. X equals negative 4. Let's look at one more type of problem. We've got solving rational inequalities algebraically. So solve the inequality 8 over x plus 5 is less than or equal to 4 algebraically. And then we want to check to make sure that that answer is reasonable. Okay, so we're going to solve this just like we would an equation, except because it's an inequality, we're going to have a different kind of setup here. We're going to actually have 2 cases. Once where the x plus 5 is positive and once where the x plus 5 is negative. We know that the x plus 5 cannot equal 0, because if x plus 5 were equal to 0, then that would be undefined. So we could have it less than 0, in other words negative, or greater than 0, positive, and that will affect how we solve. So first of all, let's check for where that least common denominator, that x plus 5, is positive. So if we have 8 over x plus 5 less than or equal to 4. So if we want to solve like we did before, say that we're an equal sign, well, to get rid of that x plus 5, we'd multiply both sides by the x plus 5. And remember, when we divide or multiply by a negative number, we switch the sign. But we've decided here that this least common denominator for this case is positive. So we don't have to worry about switching the sign. These just cancel out, and so we'll have 8 is less than or equal to 4x plus 20. And if I subtract 20 from both sides, I'll get negative 12 is less than or equal to 4x. And then divide by 4, I'll get negative 3 is less than or equal to x. But that's not all. We also need to consider the fact that we decided that the x plus 5 was positive. So this is one part, but we also need to look at where x plus 5 is greater than 0. Not equal to, because that would be undefined. But we said it was greater than 0 because when we set up this case here. So then x would have to be greater than negative 5 for it to be positive. So this is actually an AND statement. We have this negative 3 is less than or equal to x, or in other words, x is greater than or equal to negative 3. And we've got x is greater than negative 5. If you'll remember, a long time ago we would look at a number line because this would be an AND statement for the solution. So we would have negative 5 and negative 3. And anytime we had an AND statement, we want to look at where it overlaps. So if we've got x is greater than negative 5, and we have that x is greater than or equal to negative 3, we want to look at where those two things overlap. And they overlap right here, where x is greater than or equal to negative 3. So that part just simplifies to x is greater than or equal to negative 3. Part 2, go back and decide what happens when that least common denominator is negative. So if we have 8 over x plus 5 is less than or equal to 4, and then we want to multiply both sides by that x plus 5 just like we did before. This time, remember, when we multiply or divide by a negative number when we're looking at inequalities, we switch the direction of the sign. So these two things will still cancel, and we'll be left with 8, but now it will be is greater than or equal to 4x plus 20. Subtract the 20, we get negative 12. It's greater than or equal to 4x. So divide by 4, and you get negative 3 is greater than or equal to x. So there was the first part, but remember that we were also looking at the x plus 5 was negative in this case. We need to look at where the x plus 5 is less than 0. So here this would be x is less than negative 5. Well, this is an AND situation. Again, so we have this x is, we could rewrite this as x is less than or equal to negative 3. And we've got x is less than negative 5. So just like before, we're going to do a number line. That negative 5, negative 3. In this case, we had x was less than negative 5. And x was less than or equal to negative 3. When we're looking at AND, we need to look at where it overlaps. So that's this part right here. So that would just be where x is less than negative 5. That's the overlap, so this is where it simplifies to. And maybe this seems a little bit strange, but we now have to combine the two parts. It's AND when we're looking in each part, but then it's an OR whenever we're considering the final solution. So our solution would be the set of all x's where x is less than negative 5 or x is greater than or equal to negative 3. So we found the solutions for each part, what they simplify to, and then the final solution would be the solutions from both with the word or in between. So if x is less than negative 5 or greater than or equal to negative 3, that would include the solutions to this inequality that we were given in the beginning. Alright, that's it. I'm sure you'll have a couple of questions. Jot them down so you don't forget, and I will see you in class. Bye!